In this video, we'll use Kepler's third law to calculate the mass of an orbiting object. So here we're given the data for two moons of planets. We need to calculate which planet is heavier and by how many times. So what we need to do is we need to work out, using Kepler's third law, t squared over r cubed, for each of the planets. So we'll start off with Miranda, which is a moon orbiting Uranus, so Uranus being the planet there. And for that, we're going to do t squared divided by r cubed. Luckily, both of these are in the same units, so we can work with it. So t squared, t stands for the orbital period, the time. So we're doing Uranus, so that's 1.4 squared divided by the radius, which is 129,900 cubed. And if we work that out, we get approximately 8.94 times 10 to the minus 16. Then we need to do exactly the same thing for Saturn. So again, it's t squared over r cubed. So t squared for Saturn is 16 squared. That's how long it takes Titan to orbit Saturn, divided by the mean radius 1221850 cubed, gives us 1.40 times 10 to the minus 16. Now the way to work out the heaviest planet is the heaviest planet has the smaller value for Kepler's third law. So we can see that Saturn here has a much smaller number. So our heaviest planet is Saturn. And then to work out by how many times heavier, well then we just need to do the ratio of the two values. So we'll do the larger number divided by the smaller number. So 8.94 times 10 to the minus 16 divided by 1.40 times 10 to the minus 16, which gives us approximately 6.37. So we can say that Saturn is around about 6.37 times heavier than Uranus. So very similar here, use the data in the table to determine how many times the Sun is heavier than Uranus. So this time we've got Mars as a planet, so Mars will obviously be orbiting the Sun. And then we've got Ariel, which is a moon of Uranus. So again, we're going to do the same things. So we're going to work out t squared over r cubed for Uranus. So the t squared for Uranus, t is the time of orbit, so it's 2.52 days squared, divided by the radius, which is 191,240 cubed. And working that out, we get roughly 9.08 times 10 to the minus 16. And then we can do the Sun. So t squared over r cubed equals the Sun. So we've got 687 squared, which is how many days it takes Mars to orbit, divided by the radius. Now it's in standard form here, and if you've got your scientific calculator, you can just keep it in standard form. Makes it easier than trying to convert it. So doing that, we get 3.58 times 10 to the minus 20. So we said that the heaviest object is the one with the smaller value, and you can quite clearly see that the Sun has a much smaller value because it is many times heavier than Uranus. And now we can work out exactly how many times by dividing our larger value by our smaller value. So 9.08 times 10 to the minus 16 divided by 3.58 times 10 to the minus 20 gives us approximately 22,801 times. So in the trickier question, it's very similar, but this time the data that we've been given has got non-matching units, so days and years, kilometers and astronomical units. So we need to sort that out first. So first I'm going to change kilometers into astronomical units. So to do that, I need to divide by 1.5 times 10 to the 8. So 421,600 kilometers divided by 1.5 times 10 to the 8 gives me 0.00281 astronomical units. It's actually a bit longer than that. I'm going to keep it in my calculator so I use it accurately later. Also 12 years, I'm going to convert that into days. So using the fact there's 365 days in a year, 12 times 365 gives me 4,380 days. Now that we've made the units the same, we can do exactly the same thing. So we can work out the t squared divided by r cubed for both Io and Jupiter. So for Io, it would be 1.769 squared. That's the orbital period t, divided by the radius cubed. So that's 0.00281 cubed. I'm working that out with the exact number on the calculator. Gives me a very large number, 140937848. And then I can do the same thing for Jupiter. So for Jupiter, it'll be 4,380 squared divided by 5.2 cubed. And working that out gives me 136,438.8. So we can clearly see that the Sun is much heavier. And again, we knew that it would be because the value here is much smaller. So to work out how many times, we just do the bigger value divided by the smaller value. So the bigger value here divided by that gives me 1,032.9. So that we know that that the Sun is approximately 1,033 times heavier than Jupiter.